G'day everyone and welcome back to this geometric figures series. This is all doing with similar figures in this video. We have previously looked at congruent figures, figures that are exactly the same. In this one though, we have similar figures. Similar figures look the same but can be bigger or smaller depending on what we're doing with it. Now, what we're going to be looking at is how we're going to work with that in this video. We're going to start by having a look at enlargement and scale factor. So scale factor is something that we haven't looked at before. Okay, and scale factor is the number it is a number by which you multiply so you're going to multiply this number each length, right? So by each length or each side. Each side length to either enlarge or reduce a shape. Okay, so we're going to either enlarge or reduce the shape by this scale factor. Now you can see in my little diagram here that our enlargement so enlargement is where we increase the size. Okay, so that's what we mean by enlargement. And we have our little diagram here. We have an original triangle. All right, we have our original triangle here with 4, 5, and 6 on the outside. We want to use a scale factor of 3. So here, well, that's 4 times 3. This is 5 times 3 and 6 times 3 in order to get our new side lengths to enlarge our shape. Okay, to get to the scale factor, we use scale factor equals the image length or the new length. I'm going to put that in a really bad spot. Goes over the original. Okay, so we have scale factor is image length over the original length in terms of what we're looking there. Okay, now last little bit to think about for this one, if our scale factor is greater than 1, we have an enlargement. And if our scale factor is less than 1, we have a reduction. Okay, so that's where we're at with this. We've got our scale factor all worked out. We know enlargement is increasing, reduction is actually making it smaller. We know how to find our scale factor. Now in terms of similar figures, we need matching angles. So the angles will be the same no matter what. And pairs of matching sides all right, that have the same proportional ratio. That's what we need. Okay, now we do have a symbol for similar figures. And the symbol for similar figures is 3 parallel lines that are vertical. Okay, so 3 similar parallel lines that are vertical. So if we look at our little image here, all right, we have our original, and then we have a scale factor of 2, and we have our new shape. So we can say that the shape A, B, C, D is similar, using our little symbol, to F, E, F, G, H. Okay, and we usually write our letters in matching order so that they correspond with each other. So where the A is, that's where the E should be, the B with the F, C with the G, D with the H. You can see that we've got that scale factor of 2. Well, how did we find that? Well, we've got 2 sides here. We've got a side of 5 and a side of 10. So we use our little formula that we used before, or that we saw before, of the image or new length. We call it image length, simply because sometimes it's just based off an image over the original length. Okay, so for these purposes, we're going to have that scale, which is the image length, which is 10. So our new length is 10, and our original length was 5, which gives us that 2. Okay, and you can see there that our corresponding angles, alright, so this angle here, same size as that angle there, and you'll see that all the way around those shapes. Now, something to remember in terms of different shapes that we are looking at, okay, is that all squares are similar. Full stop. Just by the nature of what squares are and how you get to a square. If you watch the quadrilaterals video, you'll understand why squares are all similar. It's because they all have 90-degree angles, or their sides are the same length. So when you do them in proportion, they're going to be the same. So it doesn't matter how big or small you make a square, those angles are all going to be 90 degrees, which is going to help us out. Similarly, all circles, all of our circles are similar. Alright, because they're round, they're all round, they all have the same roundness. If they're not round in the same way, they're not circles anymore. You can get ellipses and ovals and all that sort of thing, but you're not going to have circles if they're not similar. And then our last little one for that, all equilateral, if I spell equilateral correctly, triangles are similar. Okay, because that same reason for the squares, we have those angles, those 60-degree angles in the equilateral triangle, because remember, it has to add up to 180 and they all have to be the same. So they're all going to be similar as well. And we've just got that extra little diagram there to show you what's going on with the squares. let's have a squiz at an example or two. Here we are. We have some similar figures. We've been told that they're similar figures. First thing we want to do is find the scale factor. So scale factor equals the image over the original, and we can shorten these as long as you know what you're putting in. And we need to select two sides that are the same on those images, on those diagrams. We can see here that this 4 centimeter side is corresponding with the 6 centimeter side. So what I need to do is I need to put the 6 over the 4. And once I've done that, I get 1.5. Okay, or you can write it even as 1.5, or you can even write it as 3 over 2. It doesn't matter, all three of those numbers have the same value. Okay, we now want to find the value of y. So the y is this one here, and I want it to correspond with this 7.5. Now I'm going backwards for this one. So I'm going to divide this time 7.5 by 1.5. So y equals 7.5 divided by 1.5. And if you're quick enough with a calculator, whack that in and you should get the answer of 5. Now I want to find the value of x now, so that's our remaining distances, the 3 and the x. But I'm going from small to big now so I can multiply. X equals 3 times 1.5, and you'll get 4.5 if you're quick enough on that calculator. And the only thing missing there is the centimeters, because you should always include your units of measurement. Alrighty, next example, we've got a shape there, and we want to use these to create some new shapes. What we're going to do is we're going to use some scale factors that I haven't actually included in that sheet, so I should probably put them in here. In our first one here, for A, we're going to use a scale factor of 1/2. And for our other one, we're going to use a scale factor of 3. Okay, so if I'm going to have a scale factor of 1/2, I want to go halfway. So if I use my trusty ruler, I can pop that measurement there, and I can see that I am 1, 2, 3, 4 centimeters. I only want to go halfway with this. So going halfway, I should be able to get just to the 2. Make that one a bit bigger. And then I do the same with the B. So I find out that distance. This one is 1, 2, 3. So I want to go 1.5. And again, I get the other one, and it's 1, 2, 3, 4, 5. So I want to go 2.5 to make my new triangle. So I'll just make some dots there. If I make that a bit bigger, so you can see it a little bit better, Alright, so you can see that those dots are halfway between the dot I'm looking at and the 0 or the O. And I can make that line up. Join those lines. Join those lines. And now I have a new triangle that is half the size of the original one. And I can label the sides with a little dash to say that they are similar, but they are not exactly the same. Okay, so that's going smaller, and all we're doing there is I'm taking these two dots and essentially just measuring along this red line. And doing that for all three sides. Okay, let's zoom back in and let's have a look at our next one. Our next one there is scale factor of 3. So this time I actually want to go bigger, so I need to come out this way. And I might use my trusty red pen again. And let's put those lines in so we can see them a little bit better. So I'm going to go this way, and I want a red line. I'm just going to use that red dotted line. I'm just going to go all the way out here, because I don't know how far I need to go yet. I'm going to do that same for B, and then for A. So this red line will be a guide, and we do the same for A. And now I'm going to put outlines across those. So let's get our measurements done. Let's start up here with C, and C is and C is 1, 2, 3, 4 centimeters difference. All right, so I want to go 4 times 3. 4 times 3 is going to get me to the next bit, which is going to be at 12. Okay, so it needs to go 12 away, so I've got 4. Get back in that spot there. So 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, so there's our first spot. Give it a nice orange dot. Do the same thing for B. And it's 3, so same distance as before. So I want 3 times 3, so now I want to go to 9. So I want 3, 4, 5, 6, 7, 8, 9. Put my orange dot there. And do the same for A. A is going to be a bit further, so I might need to maneuver a little bit. And you see that one's 5, so it's 3 times 5, which is 15, so I need to go to 15. So that's 5, 6, 8, 9, 10, 11, 12, 13, 14, and I do need to go a little bit further. Make sure it all lines up. 15, and put my orange dot in, and then I can join up those orange dots. Hopefully they all line up. Alright, you can see it coming together. Bob's your uncle. Alright, and we can just pop those labels in again. Alright, so C dash, B dash, and A dash. Have fun drawing these constructions. You can see there's some questions there from the Cambridge textbook to do. Have fun with them. If you're not quite sure, you can chuck in questions below as to how to do particular bits and pieces, and I'll do my best to answer them. In the meantime, good luck with those questions, and thank you for watching.